Okay, so in this video we're going to be looking at integration by substitution. Okay, which is a very important topic and it comes up a lot of times in exam questions as well. And we'll sort of set the scene. So let's consider the integral, which you could do from higher. Okay, so let's consider the integral x multiplied by x squared plus 3 to the power 4 dx. Okay, so you could actually do that from higher, but what you'd had to have done is you would have to have multiplied out all your brackets. Now that's to the power 4, which means that you'd have 4 of those brackets and multiplied them all out, and then you would have had to have then timed down by x. It took a long time to do so. Okay, so it's not impossible, but it could be done. So what we can do now to make it more efficient, right, so to make it more efficient, we can change the variable by substitution. And if we're clever with the variable in the substitution part, we can make this question a lot more easier. Okay, so let's actually do it fully now. Okay, so example 1, same question. X multiplied by x squared plus 3 to the power 4 dx. Now normally, if it's a question about substitution, they'll tell you what the substitution needs to be. They'll give you that information. Okay, some worksheets, some textbooks, you have to find it. But what normally is the case, it's the bit that's the awkward part, is the substitution. So it's the bit inside this bracket that's the problem here, because it's the power 4. Okay, that's the bit that would take a long time normally. So let's let u equal x squared plus 3. Okay, so I'm letting u equal x squared plus 3. So that way, I'm going to swap that x squared plus 3 for a u eventually, okay? But before I do that, I'm going to differentiate this function with respect to x. So I'm going to go du by dx. Okay, and if I differentiate that, I get 2x. Now, what's going to happen also is I'm going to change all this in terms of u's, which means that I need to change the dx to a du eventually. So what's going to happen here, I'm going to have to substitute dx out. So I'm going to rewrite this in terms of dx, which would be du divided by 2x. Okay, so I've just rearranged that for dx. Okay, so the first step is you differentiate what it's asking you to do as a substitution, and then we'll just rearrange that to get dx equals. Okay, now let's see what happens when we put that information into our question. So that becomes the integral. Okay, well x is still there. I've now got x squared plus 3, which I was told could be u. So that's u to the power 4. Multiplied by dx. Now dx is going to be du over 2x. Okay, so I've just substituted that there. And what normally happens is things can cancel. So that x and that x will cancel. So I now have no more x's left in my question. I can bring that half, let's change the pen color, I can bring that half out to the front. So I'm left with u to the power 4 du, which is a lot simpler to integrate. Okay, I can just integrate using my rules from higher last year. So that becomes half of u to the power 5 divided by 5 plus c. Okay, that 2 will multiply the 5, so I'm going to get u to the power 5 over 10 plus c. Okay, so a lot more straightforward to integrate. Now the last step, so now that I've done the integration, I've got my final answer, I just then resubstitute what u was. U was x squared plus 3, so therefore it becomes x squared plus 3 to the power 5 over 10 plus c. Okay, so that's how I could integrate that awkward looking function a lot quicker by doing the substitution. Okay, so that's the scene for the first example. We'll look at a few examples to show you it can make it a lot easier. Okay, so let's look at example 2. So we're going to have the integral of sine x root 1 plus cos x dx. Okay. Now, just before we even start this question, we can write the root as to the power of half. Okay. Now, the substitution that we're allowed to do for this question, it tells us to let u equal 1 plus cos x. Okay. So, if I differentiate that with respect to x, I'm going to get du by dx. And we should know from higher that if I differentiate 1, well, that goes away. Differentiate cos, I get negative sine x. Okay, so just differentiate it. I'm then going to rearrange this so I get dx. So dx is going to be negative du over sine x. Okay, and now I'm going to put things back into my question. So I'm going to have sine x. I've got 1 plus cos x, which I was told to make u. So let's make that a u. That's u to the power of half. And dx becomes times in negative du over sine x. Okay. So again, we've still got x in the equation, but luckily that sine x will cancel off with that divided by sine x there. They'll cancel. I can bring the negative down to the outside. So that becomes a negative integral of u to the power of half du. Okay, which is what I could do from last year. Okay, so if I integrate that, I get negative u to the power of 3 over 2 divided by 3 over 2 plus c, and rearranging, I get negative 2 lots of u to the power of 3 over 2 over 3 plus c. Okay, so that's me finished with tidying up. The very last step, my question still got u. I need to substitute what u was back in. So I get negative 2 lots of 1 plus cos x to the power of 3 over 2 over 3 plus c. Are we good with that, folks? Yes, okay, so there's 2 examples. Hopefully that set the scene. It's a very systematic way of how we go about it. Okay, the steps at the start about finding derivative and rearranging always happens. Okay, so we'll look at a couple more examples just to finish it off. So example 3, we've got the we've got the integral, of x multiplied by x minus 4 to the power 6. Okay, with respect to x. Now here we're going to let x equal, not x equal, my apologies. We're going to let u equal x minus 4. So if I differentiate that, du by dx just becomes 1. And then if I rearrange for dx, I just get dx equals du. Okay, if I rearrange that in there. Okay, so now let's put everything back in. So that becomes integral of x minus 4 is u to the power 6, and dx becomes du. Now this is the first time we've got a little bit of an issue, because what we want to happen is we want just the question to have u's now, so we can integrate with respect to u. But you can see here I haven't been able to manage to cancel any x's, this x off here, this x is still there. So what we do is we're going to rearrange what it told us the substitution to be. That substitution says that u equals x minus 4. Therefore, if I rearrange that for x, that tells me that x has to be u minus 4. So I can swap that x out for a u minus 4. That's going to multiply u to the power 6 du plus 4. Sorry, I've wrote that as a negative 4. That should be plus 4, because noticed there, plus 4. Okay. Multiply my brackets out, so that's going to be u to the power 7 plus 4 u to the power 6 du. Integrate it now. U to the power 7 becomes u to the power 8 over 8 plus 4 u to the power 7 over 7 plus c. And then last step, in fact I don't need my square brackets anymore, so let's drop that out. I can just swap the u's for my substitution. So u was x minus 4, so that's x minus 4 to the power 8 over 8 plus 4 lots of x to the minus 4 power 7 over 7 plus c. Okay, so that example there just shows you sometimes still have an x variable left, and you have to go back to your original substitution to just rearrange it to get rid of that and swap it for a u as well. Okay, I'll give you one last example, and the last one's going to be when partial fractions kick in as well, which you have seen earlier on in the course as well. So example 4, we're going to have the integral 1 over e to the power x plus 1 dx. Okay. Now here we're going to let u equal e to the power x. If I differentiate e to the power x, well, I still just get e to the power x. That's one of our rules in a formula sheet. And if I rearrange that, dx will be du divided by e to the power x, which is in this case du divided by u. E to the power x is what I allowed u to be, so I can swap that e to the power x for also a u. Okay. Now let's put this into a question. So we'll have 1 over e to the power x is a u, so that's u plus 1. dx becomes du by u. Okay. So that becomes 1 over u to the power, u bracket u plus 1 du. Okay. So that's why partial fractions occur, because I can split using partial fractions. Okay, so if I just focus on the actual fractions, so I've got 1 over u bracket u plus 1. That's going to be a over u plus b over u plus 1. Okay. If we then tidy that up, that's going to be a with the bracket u plus 1 plus b times u over u bracket u plus 1. So therefore 1 will equal a u plus 1 plus b times u. Okay, so if we let u equal 0, first of all, that will cancel the b constant, so therefore I'm going to have 1 equal a, so therefore a is the value 1. If we then let u equal negative 1, that will cancel the a bracket, so therefore 1 will equal negative b, therefore b equals negative 1. So the integral I had, 1 over u bracket u plus 1, becomes the integral of 1 over u, because b is negative, minus 1 over u plus 1 du. Okay, so that's just me using partial fractions to split that up. If I then integrate that, that becomes log of u minus log of u plus 1 plus c, okay, minor constant plus c. I can then substitute back out my u, so that becomes log e to the x minus log e to the x plus 1 plus c. And then the very last thing that can tidy up, you should spot that log and exponentials are inverses of each other. So that's just going to remain with x, so x minus, I can't do it with that one because it's e to the power x plus 1, so that needs to stay e to the power x plus 1 plus c. Okay, so there's 4 examples on integration by substitution without any allowance. Okay, folks?